So today's problem is problem number 18 of the MIT 2024 Integration B regular season, which is the definite integral from x equals to 0 to x equals to 1 of the product of the square root of x to the power 8 minus x to the power 6 plus x to the power 4 and the square root of 1 plus x squared. So thank you so much for tuning in. Thank you, our subscribers. Thank you for the support that you continue to show us. We treasure that. For our first-time visitors, what we do here is we just do mathematics. We love mathematics. We share with you some of our solutions to some of the intricate problems that come our way. For our repeating visitors who haven't subscribed, we do really encourage you to spare a moment and subscribe to our channel. Your support will go a long, long way in giving us that extra visibility that we need. If you like the video, please don't hesitate. Just click on that like button. You could also click on the notification button so that you get regular notifications whenever we come up with a video. So this problem is interesting. My simpler version of the solution is first, I would like to combine those square root signs so that we have one big square root sign. So I would just multiply x to the power 8 minus x to the power 6 plus x to the power 4 and 1 plus x squared under the square root sign. So what happens here is essentially this part here times 1. So we have this. And then the same part here times this, right? So x to the power 8 times x squared is x to the power 10. X to the power 6 or minus x to the power 6 times x squared is minus x to the power 8. And plus x to the power 4 times x to the power 2 is x to the power 6. Now what we see here is this one here and this cancel. And this cancel, right? So we are left essentially with these two components. So, and that is x to the power 4 plus x to the power 10, all under the square root sign. Then we can pull x to the power 4 out, and when you get the square root of that, we have x squared, and then 1 plus x to the power 6, which is interesting. And the next step for us is to say, okay, let's combine this x squared and dx. And we see that if we let u be equal to x to the power 3, that means that du dx is 3x squared. And so a third du can be substituted for x squared times dx. So this here is the same as this, right? And so we can substitute that for that block. Now, when x equals to 0, for the lower limit, u is equals to 0 to the power 3, which is 0. When x equals to 1, u is equals to 1 cubed, which is 1. Right? So this limit here can be substituted appropriately. And so for our new integral, in place of du, in place of dx, x squared dx, we have a third du, so we pulled out a third. In place of x equals to 0, we put u equals to 0. In place of x equals to 1, we put u equals to 1. And in place of 1 plus x to the power 6, we have 1 plus u squared, because x to the power 6 is the same as x cubed squared. And so we can then go ahead and say again, let u be equal to tan theta, such that du d theta equals to sec squared theta. And so du can be substituted for, or sec squared theta, d theta can be substituted for du. Now, Let me also just do one more diligence. Since u is tan theta, when u equals to 0, that means theta is equals to arctangent. Just my preference to represent arctangent like that, which is equals to 0. When u is equals to 1, sorry, now when u equals to 1, theta is equals to arctangent of 1, which is equals to pi over 4. So the limits, the lower limit is 0, the upper limit is going to be pi over 4 in the theta domain. Therefore, a third integral from u equals to 0 to u equals to 1 of square root of 1 plus u squared du is the same as a third. Lower limit is 0, upper limit pi over 4, square root in place of u squared, we have tan squared theta. In place of du, we have sec squared theta. And so 1 plus tan squared theta is the same as sec squared theta. We have a square root sign here, obviously. And then we have sec squared theta d theta that we substitute in place of du. So we have a third integral from theta equals to 0 to theta equals to pi over 4. Square root of sec squared theta is sec theta times sec squared theta. Now, sec squared theta can be expressed as the derivative of tangent of theta, and we can now use the integration by parts, where if we have a product of u capital U, d capital V, the integral of that is u capital V minus the integral of capital V product d capital U. And so if our u is sec theta and our v is tan theta, uv is going to be equal to, we pull obviously this constant out here, sec theta tan theta, and we've applied the limits shown here, minus the integral of from obviously theta equals to 0 to theta equals to pi over 4 of v, which we found to be tan theta, and then derivative of du or sec theta, which is sec theta d theta. So we have sec theta tan square theta. Continuing, we can now express tan square theta in terms of sec theta. So tan square theta is the same as sec square theta minus 1. And so we are left with sec cube here and sec theta here. So since this entire integral is a third integral of sec cube theta, then we do have an I here. So we have a third integral of sec theta, obviously with the limits, sec cube theta with the limits, and then in that we still have sec cube theta. So we decide to, on the left side, say, okay, we have a third, the integral I, but again here we have another I here. Now, there's this constant here, I mean 1 over 3. So 1 over 3 times I can be pulled onto the left-hand side, and we have 2 over 3 I. And we're still left with this part and this part, okay? But our integral of interest still has to be a third I. So we have to divide both sides by 2 so that our third I is 1 over 6. This part here, which has already been integrated with the limits as shown there, times the integral of sec theta from theta equals to 0 to theta equals to pi over 4. Now we can just apply the limits, sec pi over 4 tan pi over 4 minus sec 0 tan 0. Sec tan 0 is 0, so 0 times sec 0, which is 1, this entire thing goes to 0. Okay. Now sec pi over 4 is square root of 2. Tan pi over 4 is 1, so this is going to be root 2. Now, this integral, I can solve it easier or easily if I apply this constant here that is 1, but we express that 1 plus sine theta over 1 plus sine theta, right? So that means that we have 1 plus sine theta over cosine theta times 1 plus sine theta. This 1 here can be expressed in form of the identity cosine theta, sine square theta plus sine square theta. Okay. This one here is the same as 1. And that will help us quite a bit because then it means that we can separate it into two different integrals, sorry, and we can factor out the second part where we pull sine theta out, and as you can see, these two different integrals. In this case here, this and this one cancels, and this and this cancels, right? And then that means is that we have now cosine theta over 1 plus sine theta here, sine theta plus cosine theta. We can combine that integral again, and so we have cosine theta over 1 plus sine theta plus sine theta over cosine theta. Now, this integrated is the same as the natural logarithm because the numerator is the same as the derivative of the denominator, and then here the numerator is the same as the negative derivative of the denominator. So we have natural logarithm 1 plus sine theta minus natural logarithm of cosine theta. Applying in the limits appropriately, we have, first of all, I had to use the rules of logs where we're dividing when there's a subtraction of the two different logs. So we have to combine it to one log function and then divide whatever is under the log function. So we have the log function. So we have sec theta plus tan theta. And applying in the limits, we have obviously our root 2 there, and then natural log of sec pi over 4 plus tan pi over 4 minus natural log of sec 0 plus tan 0. So this one here is 0, this here is 1, and this one here is 1, and here is root 2. Okay. And therefore we have a constant 1 over 6 root 2 plus natural log root 2 plus 1 minus log of natural log of 1 plus 0, which is just natural log of 1. So any log of 1 to any base is 0. So we're left with a 6 root 2 plus natural log of root 2 plus 1. And that's our final answer. So kind of windy, but all the same interesting. Until next time, bye-bye. If you haven't subscribed to our channel, we do invite you to subscribe to our channel. We would really appreciate your support. If you have a question you'd like us to get back to you, please leave a comment in the comment section. If you have any suggestions or alternative methods, we would really appreciate it. We'd love to learn from you. Thank you. Until next time.